Okay, yep, we're connected. And we should be live. Yep, all right. Cool. I got the live stream going. It shows it as live. Edit. We do need to change. Let's see here. Turn that on. Done. Save. Okay, cool. That should have changed. Yep, monetize it. Okay, cool. All right, it's just getting the stream set up here. Does appear to be working correctly now. So welcome to today's live stream. I got to get used to the, I got the webcam set up, and then I also have the Sony camera set up for the actual repair. So I got to get used to having the two cameras, but I figured this was good to have so that way I could move it around and show you the PMD2 cabinet when I put one of these transceiver boards in it for testing, and I can also show you the power supply so we can see current draws if we have any going on. So that's kind of the setup for today's live stream. Office is still kind of messy because I've just been super busy lately. Gonna give it just a little bit of time so that way people can join the live stream before I get started on the repair. But let me just go ahead and grab one of these boards and have them sitting here. So this one is one that pretty sure I know the problem on it, but haven't actually prepped it. All the rest of them are prepped and ready for repair. So we'll see how that goes. So, yep, just decided I'd do a live stream because I haven't done one in a while on the channel. So that's what's going on here. Hopefully you guys like the setup with the two cameras. If this one's getting in the way of actually seeing the repair, just let me know and I can turn off that camera so that way it is not visible. So, yep. Some of the things I still need to work on my workbench here is I don't actually have a keyboard tray so my keyboard's just kind of sitting here in the way. So yeah, put that down underneath and kind of get set up here. Yeah, just giving a little bit of time for people to join the stream. One of the things that I've kind of noticed that I think I've been doing wrong on these, doing the repair, is how I disassemble it. There's screws underneath, and then there's these nuts on top. And I've been taking the screws off and taking the whole board off with the supports on there. I think it's really meant to come off this way, because I actually did the repair on one of these yesterday. And wasn't able to, it was really hard. I was able to, but it was just really hard. There's a washer that goes here, and it's hard to get that washer on when putting it together. And without the washer, well, there's another washer that goes there. Without it, it sits just a hair too low, so it does actually need that washer. So what do these boards come out of? They come out of the PMD2. It's a PMD stands for phase motion detector. It's a cabinet that's used to detect trains on railways. So I'll also type that out so that way it's in there. PMD2. All right, sorry, I can't type. Cabinet. There we go. Okay. So yeah, that's what we'll be repairing. Let me just go ahead and cut this off. I don't put the railway, they're the guys that put the cards on there, and then I kind of write my own note on the board there. Yeah, you don't see these every day. You don't. And here's something else you don't see every day anymore, but you used to see every day back in the past. Schematics that are provided by the manufacturer for repair. So yeah, right to repair, we don't have laws on that because you didn't need them in the past. They'd provide you with everything you needed. So yeah, the schematics are readily available for these. This one's for a different revision, but it's pretty much the same thing. So let's see, which revision is this? It doesn't even say. The sticker's missing. Oh, it's got revision C. This is for revision T. But same thing, and pretty much all the components are the same. Most of the things that I've noticed that have changed on the different revisions are just pieces that got obsoleted, which, I mean, most of this is obsolete today. Most of these components are kind of hard to get your hands on. So it's an older cabinet, but they're still in use. This was designed in the 70s. Some of the parts actually are stamped for the 70s. Yeah. I wish we had. I wish GM would be good about putting out schematics on stuff. But yeah, this thing's old, and you can tell it's old because the whole schematic's hand drawn, and so are all the traces. These are hand done traces that they peel and then do that acid etching and stuff. So yeah, this is old school. Long before my time on a lot of that. Yeah, so let me, I'll go ahead and start taking this one apart. Well, first let's look at it. Let's see what the problem is. So if you saw my note, probably can't read my terrible handwriting, but it says pulls 5 amps on it, which is the limit of what I can get it to, what it'll pull on these. Go ahead and turn this on. All right. Y'all probably won't be able to hear it. It's kind of quiet. I don't know. Y'all hear my thing? So, see, this one is the common rail here. Y'all can't see very well. Let me prop it up so that way you see it better. All right, so this pin is common, and this one is 12 volt positive. So we got a dead short across 12 volt positive. This one's 12 volt negative. No issues there. So 24 volts, but you'd see 24 volts between that. So common's where you're measuring from. So yep, got a dead short on that rail there. Now, I say I haven't pre-gamed this repair because I haven't actually verified that the component's bad, but this is the same problem I have on the other 4 of them that I'm repairing, so pretty sure we know the issue. Oh yeah, leaded solder too, nice and shiny. Yeah, everything's leaded solder. So the way I had been taking them apart is taking these screws off to take this off. I did one of these last night. I put it back together. Pretty sure that I'm supposed to actually take it apart this way. So we're gonna try to do that on this one, so that way I don't have to fight with those washers putting it back together. So let's see, is this like everything? Yeah, this is everything else, the same way. Okay, let's get these off of here. And yes, the conductors are through these rods here, so we do have to make sure that these guys make it back on the ones that have them on the top. If they have a trace on the top, they have it up top, and if they don't, they have it on the bottom. The trace will be on the bottom instead. And these are the same ones I did the short video on. I did a YouTube short on them. There's a company that actually specializes in repairing these, and they had the resistor that was just kind of flapping in the breeze there. All right, and so that's all there is to getting this board off. So yeah, definitely I was doing it wrong. This is definitely the right way of taking them off, is that way. So you see some of these have these guys here, so let's put them on there so we don't lose them. Actually, all of them have one on the bottom. Only the one had a trace on the top, so that one just needs it also. How is the audio? Does it pick up my AC really bad? Oh, let me move this camera. You can't really see me. The whole point of that camera is so you can see me. And let me take a look in OBS so I can see it better. Yeah, that's a better view. But yeah, so let's get this transistor off of here. And just let me know if the audio sucks. So these have heat sinks on them, and then these two don't. One's an NPN, the other is a PNP transistor here. And this one is the PNP that's been going out and taking down the whole board on some of the other ones, giving that short on it. So we'll take this one off and see. This one over here, although it looks like a transistor, is actually a optocoupler. And I've seen a lot of these where they're getting hot, they're melting the little seat that they sit on, but I haven't seen any failed ones of these. And this part is obsoleted, and I cannot find anyone that's reproducing it, and I can't find any new old stock of it, so I'm gonna... I've seen some of these boards that the company that repairs them has replaced these on them, so I do know that they do go bad, so I'm gonna have to find some stock of these to use for replacement in the future. But yeah, let's just start with taking off this transistor. I'm just waiting on the desolder gun to heat up. I'll go flip it over. And since this is a live stream, I'm not going to be able to edit out the awful noise of my fume extractor, so y'all are just going to have to hear that, because this new microphone, it picks it up. I do have the noise canceling mode turned on, so it kind of makes a weird sound. Sorry, yeah. I'll have to work on the audio sync for the live streams. I actually hadn't I didn't check that at all beforehand. So because yeah, the webcam is not going to need the same delay as the big camera, and I do have a delay on the audio setup for the big camera. I didn't even think to check that. So hey, 12. Okay, we have 5 viewers right now. We got 9 viewers. Cool. That's actually pretty high for my channel. I generally don't get that many viewers on here. So another problem I've been seeing with these transceiver boards is, so this board here, it just connects by some pogo pins right here, and they're just sitting in there, and you'll see them start to turn green. They'll be super corroded, and it'll act like it's working, but it won't. It won't pull down the MD line. So definitely just taking this off, which is the 2 screws. You just take these 2 nuts off and slide it off. Clean it with some deoxit. So this stuff right here, clean it real good, and it brings it back to life. So seen a couple of them like that. I already took care of those. So yeah, that's heated up. So we'll go ahead and get it off of there. So that is this one. Yeah, I already put the flux in it. All right. So there we go. We got it out of there. Let's check and see if we still have our short across that rail. This one looks like it's been replaced before because it is not the Motorola. The original ones are made by Motorola. All right, let's see here. All right, well that did get rid of our dead short across it, so it was the problem again. These ones that have been having this problem have all been labeled lightning strike on their cards, on the little paper cards on there. So I guess they're just a little more sensitive to it. In the rail, you know, lightning strikes are a common problem in the rail world because the sorry, still trying to focus on that camera. Lightning strikes are a common problem in the rail world because they have the whole rail line out there's a giant conductor that's going to get struck by lightning. So yeah, when they first were telling me that was their problem they were having with most of their stuff, I was like, oh, come on, lightning strikes aren't that common problem. And then I realized, oh yeah, you got this giant steel rod in the ground going across it. That makes sense. So yeah, they seem to have broken boards every time there's a storm, and luckily Florida, we have a lot of storms, so that means business for me. So yeah, let's go ahead and test this. We'll verify that it is broken. So I just use this cheap little transistor tester, and it gets the job done. I would not trust this thing for super accurate readings when you're trying to, say, match MOSFETs for an amplifier, and you know you need your RDS to be the same on all those MOSFETs. I wouldn't trust this for that. I'd actually want a real LCR meter for that. But this works. This is a great little tool for if you are, you know, just trying to test a transistor and see if it's working or not. So let's see. Can you see? Yeah, it is showing up on that camera. Oh, red one popped off. All right, so we'll test it and we'll see if it's dead. Self-test mode. Okay, so yeah, there's clearly just a dead short across it, and well, almost a dead short. Yep. So definitely got a bad transistor here. So we'll replace this. So this one's a bad one. Now these had been obsoleted by the manufacturer, but yet luckily a different manufacturer picked them up. So they are still in production. What is the company name? Oh, they're not listed on here. It's like Chicago or Century. Century is the manufacturer that picked them up. So they are still in production. It's the exact same part. Just not by the original manufacturer. Patent probably expired, or they bought the rights to it. Not sure. All right. Just trying to get it where it's sitting purely cosmetic, but trying to make it sit relatively even on there. That way it's not all crooked. Cool. Totally just a cosmetic thing now. All right. There's fume extractor for your annoying sound. All right, let's check what this. Yeah, yeah. One day I'll spring for a real LCR meter too. After I feel like paying $2,000 to $3,000. I'll have to get into amplifier repair more before I spring on a real LCR meter. All right. And yes, you should not trim them after soldering. If you do trim them after soldering, just reflow it, which is what I'm going to do. Find that leg that went flying off. Looks like it flew somewhere that way. All right. Okay. So that puts that back on there. And it's a brand new one, so we know it won't have a dead short across it. Just making sure I orient it. Yep, I did orient it correctly. Okay, so now all we have to do, put this back together and test it. So, get one of these guys on each of these. I use a JBC, I think it's CD 1 Bravo or something like that. Let me look. It's on the back of it. See, yeah, CD 1 Delta. So it's a JBC CD 1 Delta. It's an older one, not super old though. It's kind of expensive. I would not recommend them if you're gonna buy new. But I got mine used and I got a good deal on it. But yeah, if you're going new, like if you're just one of those people that won't buy used equipment, I'd recommend a Hako or Heiko or however you want to pronounce it. Everyone pronounces it different. They even Hako pronounces it different in half of their advertising videos. So I don't think they like Hako though. So yeah, if you're gonna buy something brand new though, definitely I would not recommend JBC. They're quite expensive as a new product. Yeah, yeah. Well, I will take care of those boards when they get here. Yeah. So guys, I won't name the railway that that does these, obviously for their privacy, but they do watch my channel, so I have to watch what I say about them. I can't talk crap on the technicians because I know they're watching. All right. Cool. All right. And let's see, is this one of them? Some of them, this resistor gets burnt up here. This one looks fine, though. So yeah, we got it all the way back together. Just double check that we don't have a dead short across it, and I will put it back in the cabinet. Yep, no more short across it. So let's put it back in the cabinet and test it. All right. And let me I'm going to move this camera so that way we can see the power supply. So let me check that. Yep, you can see the power supply just fine. So camera looking at camera there. All right. Make sure wired up correctly. Yep, I am. All right, so shouldn't get above like 1.7 amps at any point in time, and it should be above about an amp once the whole thing's running. So okay, it's running. The phase is looking correct on the screen. So I have phase and RX, and it takes it just a minute to turn on the MD light. So now we can see that we're no longer pulling 5 amps on that screen. I'm going to bring this down so that way you can actually see what I'm talking about on these lights. So right here we have it just shows if it's in the normal operating range, if they're setting the island, if there's something on it, or the adjuster off. And then phase, RX, and MD. The RSO light is for this here, which is used for like if a train is parked on the tracks. These guys don't set up their cabinets to use RSO. So we'll never get this RSO light to come on in testing. We'll just have RX, phase, MD. These guys should pulse, and they should pulse in a rhythmic manner, which is what they're doing. So this is a successful repair here. Before, we wouldn't get any lights at all because the board would just pull it down and nothing could run. So it was bad board, and that's how we repair them. So I got 3 more or 4 more of these. Yeah, no, 3. Yeah, 3 more of them over there to fix. Let me put this back. We'll let that run for a little while, make sure it doesn't just let out the magic smoke, and let it burn in just a little bit. And then while that's burning in, I'll go ahead and grab the next one. Yeah, it's a pretty straightforward repair, especially since I spent a couple of hours diagnosing them beforehand, so I already knew what would be going on with them because they all have been presenting the same problem. These ones I've already prepped them to where I've taken it off, so I can just knock them out back to back and not have to do anything else. So let's see. Yep. These 3 I already desoldered it off of them. So we'll just knock these all out back to back and get them taken care of. So yeah, pretty straightforward. And phase is still looking good. And yeah, we're not having any problems there. So I'm going to call this one a successful repair and pull it out of there. So all right. So yep, that one's done. So it gets the it's been repaired sticker. Where are my stickers at? Here they are. It's mostly, I just put these on there so I don't forget that I repaired it. And then I just put the date on it that was repaired. That way I have that for warranty. All right, 630. And the color of the sticker lets me know what year I repaired it on. All right, so putting this on the shelf. I love having this wireless microphone. I can actually walk around the office while I'm doing a stream or something instead of that headset I used to use. All right, so we'll just cut that off. I don't need it. Put that in the trash. And we'll knock the last 3 of these. Yeah, I need to get a holder for them. It'll help me organize my bench better. I just have them loose. One of the reasons why I kept them loose for so long was I was figuring out what solder brands I like, and then I was planning on getting a holder and just hadn't got around to it. But yes, I do need to get something for holding my solder. Let me scroll through these real quick and see if I missed any comments. Okay, cool. It does look like I got them all. So yeah, we'll get started on doing the next couple of them. These next couple, though, I probably won't do testing because I don't want y'all to watch me struggle to put this washer that goes here in between all of that because I have to put a screw in. And yeah, I'm just going to put these 3 together, and then we'll look and see if we have anything else to work on. So that'll be that. Where did I put the transistors? There they are. Yeah, I got lucky on these, that these were still in production. They're still in production for military contract reasons, is what the company that sold these as. It was the DoD transistor is what they were selling it as. So, but luckily they're not terribly expensive, so allows the repair to be feasible. All right. One of the, oh, this one's it. Yeah, I was gonna say one of these needs a resistor on it too that I hadn't taken off. So that's this one. I think the resistors just get broken from being, these guys keep them in the bed of their truck when they're not in use. And so I think it's just from them hitting other boards and stuff. It looks like it's physical damage and not like heat or anything like that that caused it. So let's see here. Just trying to get that sit kind of level. Let's see, is it sitting level? Yep. Purely cosmetic, but I like the stuff to look good. Yep, I use Kester too. That's what I ended up landing on. I like Chip Quick. I do have a roll of Chip Quick that I'm just going to use the rest of it. But yeah, it's just Kester from here on out. I think multi-core solder is too expensive and doesn't really provide me anything that Kester does not. So, yep. So one of those, it's easy to be cheap and buy like the cheapo Chinese solder, but it doesn't serve a purpose. You know, well, it doesn't pay to be cheap with it, is what I'm trying to say. Like, the cheap solder doesn't flow as good. It has more contamination in it. It doesn't look as professional. So, yeah, stick with good old Kester and happy with that. All right, so we'll solder these down, then take that resistor off of there. So let that heat up. Oh, I didn't turn on my fume extractor. I was like, I smell flux. There we go. Y'all probably can't see this one. Yeah, it's out of frame. Oh well. All right. Trim the legs on them and then reflow it. So trimming the legs can lead to micro fractures in your solder joint and lead them to failing in the future, which is why I just reflow them after I trim them. You really should trim the legs before you solder it. That way you don't have to reflow it, because then that's less heat you're putting into it. But I don't know. I find this method to work good for me, so it's how I do it. All right, so these two are ready to just be put back together, so I'm going to set them back over there, and then I'm going to replace that resistor. All right. Yes, the 2012, so you're talking the 2014 to 2020 kind of range, right? I don't remember the year range on this, but yes, I have one of them. What would you like to know about that instrument cluster? Because they're not very service friendly for repair. But yes, if you have questions, let me know. I can answer them. Well, if I can answer them, I will answer them. Low, damn it. There we go. This is getting clogged. This is a problem with these desolder guns, so you have to clean them out. That resistor's practically fallen out. Let's see here. we go. That'll work. Oh, hit the camera. All right, let's see, where did I put those? All right, got these guys. I forgot what were these? It's on the schematic. That's how I didn't even bother reading the color band. I just pulled it off the schematic. What are these? 470 ohm. All right, and that is all what this one needed. All right, so that repair's done. The 2024. I'll have to look into that. Yeah, my ANSD, or I think that's how you pronounce the company. It's spelled A Nest with Y at the end of it, all one word. ZD915. It's cloned some of the older Hacko stuff. It works good. I like it. I've had it for about 2 years. It's like $100 for one of these. At least when I bought it, they were $100. I think they're like $150 now. But they do work good. And I definitely highly recommend it as an entry level, you know, your first desoldering gun. So definitely recommend it on that, just as an entry level device. Mine's starting to give me a weird problem. I think the switch is going bad inside it. It randomly kind of like clicks on and then turns off. So it's the weirdest thing I've never seen. It just like it does it while it's off, where it'll click on and then turn off. So I don't leave it plugged in at the bench anymore. I unplug it when I'm done for the day. Weird problem. I haven't looked at it to see what it could be. All right, so that's all of these. I do have some other boards that I have not started diagnosing yet, so we can look at some of them. All right, so this one, the single plane boards or single island boards don't use it, so I don't need it. Can't do testing. So this test setup that I got going right here, let me bring the camera down. All right, so what we're looking at here is the inside of the PMD2 cabinet, and what you have here is, so it has a standby, so a completely separate one here, so that's why none of those were populated, because I'm not, you know, there's no need for me to set up both sides of it for testing. I only need one side for testing. So this is where the XCVR boards go, or the transceiver boards, which is what we've been working on. They go here. Then you have the SYDT board, the MD board, DCC board, which I did that video on these the other day on the channel on how to repair. And then you have two different setups here. You have one, if you use the RSI board, that's it. You don't put the other two in there. If you are doing the ISR, STC, and IST, those three go in here. And that is called a 3-board island, and this is a single board island. So that's kind of the setup. So I'm working with it with the single board. What I like about the single board islands is I can test all the different receivers in it. They all work with it. The 3 island ones, they have different subtone frequencies with them, and they will, you have to match these 3 cards. Well, I think it's these 2 have to be matched with the receiver or transceiver, or else it won't work. The MD light won't come on if they're not matched. So just something to be aware of when testing these. So I like this setup for testing, where I just have the one RSI board. and then that lets me test all of them. And then what you see here is a dummy load. So this dummy load is just a big inductor. And you can set it up differently for different lengths of track, because the different lengths of track will have different inductance to them. Kind of obvious, but yeah. And then the transmitter and receivers, they just tie together and then go through the inductor. So it's a pretty simple setup for testing. And then yeah, neutral and B, which is positive, 12 volts is how it's powered. So kind of a simple setup there. All right, so let me read these comments real quick and see what y'all have to say. All right. Where did you get your desk pad / tidy from? This, I don't remember. Oh, I remember where I got this. There was a technician that was closing down his cell phone repair shop, and I went and bought a bunch of equipment from him. I bought my Hacko fume extractor and a couple of other things from him. And I just got this secondhand. He threw it in the lot. So that's where I got it from. I think these are sold on AliExpress, Banggood, and Amazon. I think you can find it in all three of them. They're a pretty common one. I've seen them a lot. I'm actually about to just get a whole ESD sheet for my bench, and just just have that whole roll on there. I kind of price checked it. They make completely ESD safe countertops. The company that makes this workbench, when I bought it, but the price difference, it didn't make sense. It was cheaper to just buy the full roll of the stuff. And then the nice thing about that is, if you dig it up, if you burn it, cut it, or whatever, you just replace it. A lot cheaper than replacing an entire countertop. So that's my next thing for the workbench, is going to be to get that roll set up. So if you have any other questions about anything you see on the workbench or see me using, feel free to ask. Happy to answer them. Let's see, did I miss anything else? Yeah. So I'd have to get a shop air vacuum source for it. I don't have shop air set up yet, but it is coming soon, because I got this guy. So I just got to, I have an air compressor on the other side of this wall. I just got to start piping it and get compressed air in here. But yeah, this is a solder paste / flux dispenser, automated. I have it with the finger trigger for it instead of the foot pedal, but that's going to be used for board assembly for when I am working on setting up these guys. So this is, I haven't shown this yet on the channel, so let me talk about it for a second. This is my final version of my open source gauge pod. This one's the closed source version of it, because I'm actually going to sell this as a product. It's going to work with One Gauge's thing. They make a screen display that you can buy. It's a universal screen display, and it has a master board that controls it. And so this thing just runs off a CAN bus and can communicate with it. I have an open source version of it that, let me see, where are my boards of that? That I designed it and put it on. It's on GitHub. Here we go. So here's the open source version of it. It's pretty similar. The main difference is I changed the LEDs. So these use a Cree LED on them instead. And so, yeah, let me orient it that way. So yeah, this one uses Cree LEDs on here. And I moved the capacitor to the top side instead of the back. So same capacitor, just swapped it over there. And then I have these transistors here, which are, well, they're actually MOSFETs. These MOSFETs are for driving the three colors of it, because it's RGB LEDs, so that way you can, set whatever color you want. This one uses those, the little Chinese NeoPixel LEDs, which are not very durable LEDs, so they're not great for automotive applications. They're not something I would sell as a product, but it will work for somebody that's trying to DIY something. So, and it just uses an X27 stepper motor, and then has a stepper driver there, then the connector, a CAN transceiver, and then STM32. Sorry, I couldn't spit that out. And then, yeah, just got a little header here for doing the single wire to program it, and that's it. So it's a pretty simple design, and it works, runs off CAN bus. So yeah, this version, it's all the files are on my GitHub and stuff, so if you want to build it yourself. And then this one was sponsored by Next PCB. This one, I got JLC PCB to do it because they pissed me off when I did this video with them. So just I'll let that dirty air come out there. I did not enjoy doing that. I really enjoyed my first couple of videos I did with them, but that last one I did not enjoy doing with them. All right, so what is this one doing? What's it labeled? Okay, so no RX. It flashes every few minutes. MD drops out rapidly as well. Let's plug it into the board. Let's put the receiver back in it, or transceiver back in it. Plug it in and see what it does. All right. I do like to leave these on while I'm not working on, or when I haven't figured out what's wrong with them. All right, so this one, what am I dealing with here? Is this an MD board or is this, this is not MD. All right. It's this one. All right. Sorry, just making sure that doesn't short. And let's see what happens. Okay, so yeah, that does not work. It's not working properly. Well, there we go. Now it is working. It looks like this one has an intermittent problem. So we get phase blinking, but RX is solid. RX is not blinking at all. And yeah, so we probably won't get MD. Let's switch those two and see. Oh, that switch is seized on this one too. I can't switch the modes on it. All right. Someone needs a new switch on it. I don't have switches for doing the replacement. Yeah, we don't get MD. So I'm gonna have to pull up the schematic and print that out. So let me do that. Turn this back off. Yep, no MD light, not working. Cool. So yeah, this one is that SYDT board or whatever. So yeah, I don't have this switch. I'll have to order some switches for that. The switch just lets you switch between, if you're looking at the phase angle on the, here, let me pull this out and explain that. All right, so on the transceiver board, you have this little LCD display here, and then on the SYDT board here, you have a switch, and you can switch it, and you'll get the voltage across it, and then if you switch it the other way, you get to see the phase angle on there. The phase angle is always what I ever switch it to see, because it lets me know if it's I can tell if it's working right or not. All right, put the receiver board back in there. Oh, I don't know where to start on this, so I'm definitely gonna have to print out the schematic and we'll look at the schematic. Get that receiver board back in there. All right. I should have grabbed something else off the pile, but since we got this here, we'll look at it. All right. Gotta pull up the email. Wrong one. Email. All right, there we go. And what am I looking for? PMD2. Go. Oh, wrong one. Service manual. There we go. That's it. And find the schematic. Yeah, I'll switch this over for a second so that way y'all can see what I see. I don't have my Stream Deck plugged in right now. I forgot to plug it in beforehand, so you're gonna get to see that for a second. All right, so this is the service manual for it. And let me just find it, the page that I want to print. It's pretty long. All right, so let's see, what do we have here? Oh, those are block diagrams. I don't care about the block diagrams right now. There we go. Okay, here we go. Now we're in the schematics. All right, interconnect board. I need the PMD2 manual. This is actually the PMD1 manual. I need the PMD2 manual so that way I can get some of the. I need the interconnect board diagram of that one for designing something new. So here's transceiver. Let's go. All right, so let's see here. You look like you might be it. No, you are. What's that one? Oh, that one might be it. Yes, this one's it. Okay, so we need page 123, right? Yeah. 123 through. There's no way that's all of it. Oh, this one looks like this might be a different board design on it. All right, well, we'll print this out. So 25 through 23. Yep, 25 and 23. Control P. Oh, come on. $125. I got that backwards. All right, print that. All right, switch that back. Wrong one. There we go. That's the right one. Cool. So printing out that, and let's take a look at this. So I had not answered your question. Let me read it. So I pulled out one of the Buicks. They have the same. All right, so I am not familiar with the Buick Caprice from that time frame. Can't answer it for sure, but if you send me an email with some pictures of the circuit board, I could probably take a look at it. My email address, you can find it on the About section of my YouTube channel. You just go to About. You have to be on a PC. It won't work on a phone. So on a PC, go to the About section of my channel, and it'll have like commercial inquiry or whatever. Just click that. Shoot me an email with some photos of the board, and I can at least look up the chip, see what's all on there. But yeah, I don't think I'm familiar with that one. I don't think I've done one of those. So yeah, just shoot me an email with that, and I'll take a look at it, see what I can see. But yeah, it's probably on the microcontroller for it, maybe on the EEPROM though. So nice thing with those, if it is just that same ST chip, like if it is the ST30F772 Alpha, which is on the trucks from that time period, that one is pretty easy to JTAG into. They didn't use any of the security features on there. And you can dump it and program it. You can do it very easily with a Seger, with one of their products. They're kind of expensive. There are some open source versions on OCD, but I have no idea how to use them. So definitely something to be aware of is you can get the educational Seger for like $80. You're not allowed to do commercial work with it though. So the license is only for doing personal or education kind of stuff with it. So yeah, definitely something to be aware of. So all right, that's printed. Let me go grab those. I prefer to work with them printed out than on the giant scan. All right. So let's see which one goes to MD on there. So that is pin 5 goes to the MD. Oh, it's got a lot of them going to the MD board. Okay. So this right here, what I'm looking, oh, y'all can't see it because the camera's in the way. Let me move that. All right, so this section of the schematic, this one is the pinout of the connector. So if I remember correctly, yeah, let me look at the other one so I can remember the order of them because I know. All right, so yeah, so the lower number, so this would be pin 1 and this would be like pin 22. So that's the order of them they go in on here. So let's see here. Just taking a look to see if that was broken. All right, so we have pin 3 goes to MD. So let me just mark that with a marker real quick. Sharpie works great because you can clean it off with rubbing alcohol. So I'm just going to mark all the ones that go to MD for testing. So you go to the MD board, 5, so 5 goes to MD. Yep. Let's see here. 6 and 7 are the voltage rails, but so these two are power, but we don't have any power issues. It's not overheating. All right. So 9 and 10. So these two go to the MD board. 13. All right, and you go to MD. All right, and then a bunch of these down here go to the transceiver board, so that could also be the issue. So that's where we'll start with on this. Yeah, all right. Oh, you retracted your message. I wanted to see what it was. I didn't get to see it. What was it? Oh, I can't pull it back up as the administrator. I don't know what Supercharger said, so I don't know. He retracted it. But okay. Yeah, that one I'm just not familiar with enough to really know the answer, but yeah, probably I would assume JTAG. Okay, so we got some rails to look at to give us some ideas of what could be problems. So looking at the schematic, things that would... This is a board I actually haven't worked on yet. I thought I was grabbing an MD board. They look kind of similar. This is the first one I grabbed. Oh no, it is missing some of it because there's more going this direction, and it definitely didn't have it from that. So let's see. Or no, this is the more going this direction. There's more going that direction that's missing. Okay, and this is the correct orientation of it. So I need to cut that. This is from the way it was scanned. That's why it looks like that. All right. Looking for the ones that go to MD on here. Oh no, all the ones that I need are on the portion that's cut off too. All right, so I will not be working on this one. I'm gonna have to request some more schematics from it. Okay. Oh, you just said hi, and that's what you retracted. All right. Sorry, I was just curious. Okay, so I can't work on this one. I don't have the full schematic, and this one's not. I'm not familiar enough to work on that one without it. Oh, I got a whole pile of MD boards right here. All right, these are all MD boards. I knew I piled them up somewhere. Actually, not all of these. I see one that's not. Oh, yeah, these are all MD. So, producing high phase will not hold. So my theory on these is that the 555 timers go bad on them because I've seen a bunch of them with replaced 555 timers. So these ones may not be good for doing a video on either though because I'd have to pull them off. So there is one that I robbed parts off of. I can put those parts back on because I ordered the new ones now. This one's got some nasty corrosion on it. See, I didn't think I was going to knock out those RX boards quite that fast. I thought that one that I didn't diagnose might have some other problems with it. Can I work on Honda clusters? No, not really. I mean, I can. I haven't. It's not one I'm familiar with. So yeah, I've never grabbed one. None of these are, I'm not reading any of these and them sparking interest. I'm not finding joy, as the lady says. Yeah, I may just end the live stream because I'm nothing sparking joy to work on right now. I don't feel like doing it. You know what I'll do? I will start working on one of these. I know I'm not going to repair it, but let's get started on one of these. I need to work on one of these. This one's just one I need to do, because they need them back. They need it bad. All right. So yeah, we'll start with this. So this is out of a different cabinet. This is not out of a PMD2 cabinet. This is out of a micro lock cabinet. So some of them, we see these go bad in, the other ones it's these, and then the resistors and diodes that run it. But this just outputs to the actual signal lights. So this is the DC lamp driver out of it. So yeah, I'll start with this and getting it apart. And I don't know what's bad on here other than I know it is in this area. So it's either going to be this transistor, the diodes run it, or these transistors. So we'll just start, I'll just start with one of them and just work on just one output. So there's 4 outputs. This one looks like it could be working. There's no heat damage around any, yeah, none of that looks heat damage. These 2 look like they have heat damage. Kind of hinting at these being bad, but I'm going to start with just taking that off and see. Let's see. All right, so yeah, we'll work on this for a little while before I end the live stream. It won't get finished because if these are bad, I don't have them. I do have this transistor, and then I'll need to check that diode. So I don't have a schematic to this. Hitachi has not been nice and sent a schematic, so yeah, don't have schematics. So yeah, the Micro Lock, that company, they got bought out. They're now part of Hitachi. So Hitachi Railway, or whatever they call themselves, they own it. Let's see. All right. So we just have these 2. Is it just 2? Because those are going to be the lugs for the screws. So yeah, just those 2. Yeah, I have not worked on these at all yet. I'm pretty sure they're coated in conformal coating too. Let me check that. Yep, it is coated in conformal coating. So let me see, which one did I hit? That one. Scrape away some of that conformal coating. These Micro Lock cabinets are from the 90s, I believe. I haven't seen anything older than the 90s on them. Right. Okay, so for IPC hammer, I would recommend, where's mine? Oh, where's my green one? I don't see it. I don't see it sitting around. The OBD Link LX, I believe, is the one I have. It's the green one. The OBD Link that's green. That's the one I recommend because it's cheap. It's cheap enough, and it works. So that's my recommendation. There are better ones that company sells. There's some that support USB and they work with it. But the OBD Links I would recommend just because they're supported and they work with it. Anything that'll work with PCM hammer works for that. So that's the other thing. You can just Google, the dongles for PCM hammer. If it works with PCM hammer, it should work with IPC hammer. The one that Pete Sontag makes, I forget the name of his. Some of the guys tested it. They said it works. I can't confirm because I haven't tested it, but I have got a couple of messages telling me that it worked for them. And then I had somebody else tell me it didn't work for them, so I don't know if that was user error. But I've had 2 people tell me it works for them and 1 person tell me it doesn't, so not 100% sure. So can't make a recommendation on that one. Yeah, so it's a coating on here. It's not really that shiny. Well, I mean, it is that shiny because of the coating. It's also because of my new lamp that I got up there. It's very bright. Yeah. So, yeah, that's what's going on with that. Okay. Yeah, that's conformal coating that's making it shiny. So much thermal mass. This thing may not be able to desolder it. Anyway, I got that leg. Let's see if I can get this one off. Yeah, I'm just going to take these transistors out and test them and see what works and what doesn't on them. This one, I'm treating it like an amplifier. So the amplifiers I used to work on, I could never get schematics for them. So I'm just going to treat it like that. All right. Still got some solder. We're going to use a solder wick now. Try not to stick the bill of my hat in the way. That one's still stuck. Y'all can, yep, y'all can see what I'm doing. There we go. I think it soldered itself back down. Let's see. Yep, that one's stuck again. It's loose, it's just sticking on the nut there. Come on out. You're free. It's the thermal pad that was stuck. Okay. All right. Looks like we... Okay, it goes nowhere though. Thankfully that goes nowhere. All right. I guess pushed down a little too hard on it right here, and we lost part of that pad. Here, let me turn this off. Didn't fully desolder this one when I pushed it out, so that lost part of the pad there. You can see that stuck to it right there. Luckily, that goes nowhere. It's only got a trace on that side. So we got lucky. Got lucky. That's something to be aware of. All right. Too much thermal mass on these. Need to be more careful with them. Self note, or note to self. All right. So we're going to test it and see if it works. Cool. So they are still working. So this one, all of these should be good on. It should only be either this or just the diodes that go to it. So let's take one of those off, go from there. We'll just leave that off. All right. I am still live. Okay. See here. And let me check the charge on everything though, because I am on battery operated stuff now. Plenty of charge left on my microphone, and the charger is not working on the camera. Let's see, let me look through it. Oh yes, the charger is working, it's just not showing it. Okay, cool. Sorry, just checking those. All right. That's a ton of thermal mass again. All right, so that gets that off of there. Let's check the diode. It's so hard to check this stuff because it all has conformal coating on it. Just get the conformal coating out of the way here. Just gonna check these real quick. Yes, I'm abusing my solder tip. Just trying to get places where I can actually probe. Since it's all got conformal coating, burn it off, get it out of the way. All right, let's see if anything's got a dead short across it here. All right, diode works in. Well, diode is working properly. Let's see here. Yeah, let's take that out and test it. Diode out of the way. I actually do have some of these transistors, so if those are bad, I can just replace them. So the question here is, what's bad? Is it just this diode that goes here, which has clearly got heat damage to it? They definitely got real hot. Or did it take the transistor or MOSFET down with it? I think those were PNPs. I can't remember now. All right, heat that back up. And let's see, how long have we been live for? There we go. Hour. Yeah, I'll give it a little bit longer before I kill it. Let's pull this. We will figure out what's dead on this rail before I end it. So we'll take this transistor off, and then we'll take these diode, that diode off, and I believe that's a resistor there. I'll take that off and see what the hell it is. But yeah, we'll just start it. That's not hot yet. Since we were having problems with desoldering all the way up to the top, I'm going to take some of this low temperature solder and put some of that up top. This stuff's just chip quick, low temperature solder. It makes desoldering stuff easy. We'll just flow some of that in on the top side. Should make it come off easier. So this one's the bismuth-free one. The stuff with bismuth in it, you can't use that with leaded solder. And since I work with leaded solder so much, I avoid the bismuth-based one. It's like iridium or something like that. I forgot what's in it. All right, that is clogging again. This one's starting to clog a lot more on me lately. All right. And gonna need to clean it up some more with solder wick. So, has anybody been following the right to repair stuff going on lately? I haven't been talking about it on the channel much, but I have been following it and paying attention. So kind of the main takeaways that I've been seeing lately in right to repair is Massachusetts passed the new right to repair bill on automotive repair, and auto manufacturers are fighting it right now because of course they would. That one does not really apply to a lot of consumer electronics or help us get schematics. So that one, not too worried about. So, you know, it'll set a bad example if they are able to win that fight against it. So definitely rooting for the bill to win and not the auto manufacturers. But just, you know, kind of take, oh, this is like hot snotted down. This what kind of glue is that behind it? It's glued down with something. Oh no. There's glue behind it. What the heck? How hard is this glue? Why did they do that? Okay. Luckily the glue is not too bad. Definitely glue behind it, though. Evil. Why did you glue it down? All right, let's see. Which leg is still soldered? One of these is still stuck down. Ah, I see which one. It's you. But yeah, so that's what's going on in Massachusetts, is the massholes might lose their bill there. And then the other big takeaway from it, that leg is broken, of what's going on is FTC lost their fight against Facebook on, well, they didn't lose it, but it got kicked out. They're going to have to do some more antitrust laws basically going on, which is a lot of what right to repair's fight against is, you know, some antitrust things going on, big monopolies on parts and stuff like that. And so with that setting a bad example for any fight going up against anything right now. So that kind of sets this precedence that it's okay to block this kind of stuff and not let it pass. So that's not a good thing. Another not a good thing that's kind of a good thing is in New York, they passed a right to repair bill in the assembly, so now it just has to pass the next level there. But Louis Rossman's been covering that, so I won't get into details on that. Just go check out Louis Rossman's videos on that. You can take your joy on that with a grain of salt because it probably is going to go nowhere. All right, so let's check this transistor and see if it's working. Okay, so it is working, but I do have to replace it because that leg it was definitely already broken because it didn't even move from the glued position. It's still sitting in that same angle there as how it was. So that was already broken from vibration damage, which may be what caused all the rest of the damage, was just because of the base not being connected at all caused all the rest of it. So let's see what that, because this should be pretty much out of circuit now, like that. So conducting that way and conducting that way. So yeah, that's a bad transistor. All right, so we know our bad part is that diode. The diode's definitely bad because it's conducting both directions. It shouldn't do that. Is that, let's see how you're wired. Where's your trace? Okay, so no trace, no trace. Both of them are on the top. So you go straight to the optocoupler there. So that trace goes straight to the optocoupler. This one, I don't see where it goes. Where does this trace go? Oh, I think it branches directly into this, which would be like one of these. Right? Or, there you go. That's what it branches into. So that branches into that. So yeah, because that's going to the optocoupler directly, nothing else, and it's conducting both directions. So bad diode for sure. So that would be nice if that's all's what's wrong with some of these. Now, this other one, let me go grab the other one. So this board is out of a micro-lock DC lamp driver. So it drives the lamps on a railway crossing or at the switch. I think these ones are actually at the switch, but yeah, drives the lamps at something railway. I don't work out in the field. I'm not a field technician, so not 100% sure where the micro locks are used. Okay, so let me bring this one over just for your entertainment. Here is another one of these boards that needs to be repaired, and it let out magic smoke all over the board. And there's a third one. I have 3 of these, and I'm supposed to be... the third one's in the cabinet. I actually have one of these micro lock cap. No, it's not in the cabinet. Where did I put it? Oh, there it is. It's underneath the bubble wrap. Just a great place for it. Okay. So this one, you can see clearly that these transistors are bad. All 3 of these are bulging really bad. So we know those are bad. And we have heat around those same diodes, so probably got dead short on those. So yeah, that's why I need to get started on these, because Hitachi Railway will not repair them. They go, yeah, these are obsolete. I just did one of the power supplies to one of these things the other day. So yeah, the manufacturer won't repair them anymore, so I have them for repair. And manufacturer will not provide me with a schematic for it either, so I have to kind of figure it out on my own. Well, so we know the problem with it. We know what's wrong with it, which is always what I wanted to solve in this one, is figure out where our problem is. So we got to replace these diodes. I'm just going to replace all 4 of them, but I got to order them. I don't have any, so I got to end the video here. So I think this is a good place to wrap up the live stream. So yeah, I hope you guys enjoyed it. I hope you enjoyed watching me lift a pad on this one. The receiver boards went well, I think. I need to finish putting back together those other 3 of them, but no need to keep y'all around for putting the screws back in it. We did one start to finish, powered it, tested it, and it worked. So it was a good repair in my opinion. But yeah, I'm gonna wrap up this live stream here. I don't know when I'll do my next live stream, but I do like doing the live streams because I don't have to edit them afterwards. The only thing that sucks about live streams is when you make mistakes like lifting a pad. You can't edit that out of the video. Although I normally won't edit out mistakes. The majority of my editing on my videos is editing out me saying because I say a lot. It's just my natural pause. So yeah, definitely a lot of ums getting edited out of my edited videos. So yeah, I'm gonna wrap up the video. Hope you guys enjoyed it, and I'll see you in the next one.